quality botanicals can be extremely challenging, with climate change, political instability, tariffs, heavy metals and disease threatening supply chains and creating yo-yo pricing. By instead sourcing these ingredients from plant cell culture, you can avoid many of the supply chain headaches associated with traditional agriculture, claims Green Bioactives.
So over maybe the last 10 years, a number of things have changed. So firstly, there is the demand on the land and we can't pillage natural ingredients in the same way we previously could. So there needs to be alternative solutions for producing them, especially ones where we're looking at very specific molecules from plants and not whole harvesting processes. The other side, there have been improvements in things like bioreactors, so there's better equipment being able to be used to produce this equipment. In Omnics, there's better analogies of what can work, and a demand from the industry for these ingredients across different application factors. So we start by identifying an ingredient or a molecule from a plant, and that's often done in conjunction with our partners or potential customers. For us, very much in the personal care and cosmetic space. So we look at something that's challenging for a number of reasons. It could be sustainability, reliability, but there's a technology needed to produce these natural ingredients. We will then source or discover various sources of plants, different species, and take many samples to come into the lab, where we'll try to grow those cell lines in dishes using different media. And then the high performing ones will transfer into liquid suspension, where they'll be elicited, they'll be given nutrients to help the concentration and the productivity of the molecules grow. And once that's complete, we move into bioreactors for commercial production.
How can you moderate the environment to change the output?
A lot of the molecules we're working with are created by plants in stress situations. So I always like when humans are under pressure, they produce adrenaline, which gives you fight or flight, and plants can't run away. So to protect themselves from insects, from weather, climate change, they produce these molecules that are valuable in industry. So we have to mimic those situations. How do we create stresses? And that's done with nutrients that are given in, and then things like shakers that will just help develop and produce more of the required molecules to help give us a greater yield in the finished product.
And what about the downstream processing?
It could be a basic extract that's required, it could be a highly concentrated molecule. And working with the plants, we then have the ability downstream to adapt how we produce a finished product.
Are you genetically engineering your cells? And if not, do you still need an understanding of plant genetics to inform your process, I guess?
Yeah, absolutely. So there's different types of customers will have different acceptances. So it can be from, it has to be purely natural, through to GMO light, through to full transcription factor manipulation. And it really does depend on the industry you're working in. So for example, with us in cosmetics, keeping it natural is important. However, we hear a lot now from multinational companies that 10 years ago, they may not have been interested in anything that's been genetically modified. However, there's bigger pressures they have to deal with, and things like if there's no GM material left in a remaining product, then that's acceptable, right through to others that will accept genetically modified project. But again, it varies from case to case, industry to industry. So we're focused on high volume, low input molecules. So very much personal care and cosmetics market, also where there's lower regulatory barriers to market entry, which means you can commercialise something sooner rather than later. However, we know other people are working in different areas. But what we're really looking at now, as you allude to, the costs of capex, etc., can be highly preventive, and you do have to, for your investors, you have to generate revenues and make profits. So that's something that we're focused on, working in that area, but it can evolve over time. And there are a number of companies that are working on contract manufacturing options or different parts of the process that will actually help improve yields, that will help companies down the line achieve those lower values or lower cost per kilo that you allude to.
So are you able to talk about what ingredients your business is working on specifically, or?
Yes, so I can talk about a couple. There are some that we have co-development projects that are confidential. Actually, our second one, because our first one is confidential, is a licorice root extract. So there's demand out there for the main molecule is glabridin that creates tyrosinase inhibition for things like skin brightening, skin whitening, age spots, sunspots. It's widely used across cosmetics, but it's naturally sourced from challenging areas. So it could be, for example, countries like Afghanistan or Iran, which are politically unstable, or there's climate change which impacts the production and yield. So we're able to produce that consistently month on month throughout the year. So yeah, licorice is one, and we've already seen demand from Europe, North America and Asia for that product.
Okay.
We're also looking at saponins, which is a 2026 product.
Yeah.
And that's very interesting because it comes from the Chilean soapbark tree. And the actual ingredient has application for things like vaccine adjuvants as well as cosmetics.
Okay.
But it grows 2,000 feet in the air. It takes 60 years to reach maturity.
Right.
And we're only taking the bark to actually harvest.
Yeah.
So it's not a sustainable practice.
Yeah.
And it requires something like plant cell culture to then make it viable for use in cosmetic and personal care industries. So we work very much with plant vascular stem cells.
Yeah.
So there's other companies who now are working with de-differentiated cells, which creates a slightly different pathway. With plant vascular stem cells, we have patents filed. We have actually one granted in the UK for that work, and it's been expanded overseas and two more in application. But when you work with differentiated cells, there can be vacuoles which allow water or air to get in. And with plant vascular stem cells, they don't exist, so it makes things like cryopreservation easier, which is a key enabling technology we're working on, amongst other things.
What do you see as the biggest kind of barriers to progress?
Finance is always a challenge, but it'd be great for the people and more time to do that. I think for me, the other thing I've really seen is there's a lack of contract manufacturers out there.
Yeah.
So with other areas, you can move into different types of fermentation. There's ready-to-go companies you can just put production to scale up quickly.
Yeah.
Plant cells behave in a different way.
Yes.
So that makes it more challenging. You can't just put the process into somebody who has 10, 50, 75,000 litre bioreactors and say, yeah, go ahead.
Yeah.
There's a lot of work of development to get there, to get to commercial scale.
Yeah.
We're at exciting times, so we're looking to officially launch our first plant cell culture products this year, where we'll be able to supply small amounts of samples to companies for testing, efficacy development, and later in the year then we'll be looking at quantities great enough for product formulation development with the idea of commercial launches through 2026.